In this video, we're going to take a look at composite functions. Now, I suppose the first question here really is, what are composite functions? So, composite functions are when the output of one function is used as the input of another function. So what I've got here is two functions. I've got f of x and g of x, and we can see those respectively here. Okay. Now, we're asked to find two things here. I've got this f g of x like this, and I've got g f of x. So these are composition of functions. Okay. Now, the order in which we do composition of functions is very, very important, because as a general rule, f g of x is not equal to g f of x. Okay. In extreme cases, that might hold, but generally this is the case. Okay, so f g of x, generally speaking, is not equal to g f of x. Okay. So how do we understand the order for composition of functions? Well, normally when we read, or if English is your first language, when we read left to right, okay? And that's true for maths as well, generally speaking. But for composition of functions, we do this in reverse. So we go from right to left, okay? So what we're saying here for part A is we do g of x first, and then that goes into f. Okay, so it's not f going into g of x, but this is g of x going into f. Okay, so for this one here, that's g of x into f. Okay, or f of x here, we want to be precise. So what do we mean by g of x into f? Well, what we mean here is this function g of x gets substituted into f. Okay, like we saw in the previous video, in our introduction to functions, we're essentially doing the same now. We're just substituting g of x into f. Okay, so let's put that into f of x. Okay. So what I'm going to do then is substitute 3x plus 1 where my x is here. Okay, so this is going to be 3x plus 1 minus a 2. Don't forget it's minus 2 here. So wherever there was an x here in f of x, I've replaced that with my g of x. Okay, so we get 3x plus 1 minus 2. So 1 minus 2 is minus 1. So I get 3x minus 1 there. Okay, so fg of x is equal to 3x minus 1. Now, before we move on to part B, let's just discuss one other thing here. And that's sometimes where you might be given, say, fg of, say, 2 here. Okay. Now, rather than using g of x here, we're using g of 2. So we already know the value of x. So in this case, it's much quicker now to just do g of 2. So that's going to be 3 times 2, which is 6, plus 1, so that's 7. So what I need to do now is find f of 7, okay? And f of 7 is 7 minus 2, which is equal to 5, okay? Now to verify that, we can substitute that into fg of x here, okay? So if I do now fg of 2 again, using this here, this is going to be 3 times 2. So 3 times 2, because x here is 2, minus the 1. So 6 minus 1, giving us the 5. So notice we get the same thing. Okay, so that's also 5. That's 5 here. But if we're doing it with a numerical answer here, such as fg of 2 straight away, then it's just much quicker to just substitute g of 2 in first, and then substitute that value into f of x. Okay, it doesn't matter which way of those, which of those two ways you decide to go. Like I said, it's much quicker to just go with this first way. Okay, so that's part A. For part B, then we're finding g of f of x. So again, we read from right to left now, so we go backwards. Okay, so what we're saying here is f of x goes into g. Okay, so f of x goes into g. So the way we read this is f of x into g of x. Okay, so if we substitute f of x here into g of x, so what we're doing is where we've got f of x, we substitute that into any x's here in g of x. So what I'm going to get then is 3 lots of x minus 2. Wherever there's an x here, we replace that with f of x. So 3 lots of x minus 2, and then plus the 1 here. Okay. All we need to do now is simplify this. So expand this bracket here. 3 times x, we get 3x. 3 times minus 2, we get minus 6, plus the 1. So what I get here is 3x minus 5. Okay, 3x minus 5 for gf of x. So gf of x there. Okay, And there we have it. So that's our solution to part B. So we've done two together there, or two parts together. Now it's your turn. So pause the video, have a quick go now at this practice question here on composition of functions, and then we'll take a look at a moment at what you should have got. So hopefully you got okay with this practice question. Let's take a look now at what you should have got here. So what I've got is two functions, f of x and g of x. So f of x is this quadratic here, 2x squared plus 10, and g of x is equal to x minus 1. Okay, that is a minus, so it's just a little bit formatted a little bit funny, so x minus 1 for g of x. Now, two parts again here. Part A, we have to find f g of 1. So there's two ways of doing this, like we said. The easiest way is to find g of 1 first and then substitute that into f of x. So let's do that first. So part A, what's g of 1? So g of 1, well, we substitute 1 here instead of x, so that's going to be 1 minus 1, which gives me 0. So what I'm doing now is finding f of 0. Well, f of 0, if we do that up here, that's going to be 2 lots of 0 squared plus 10. Well, 0 squared is 0, times that by 2 is also 0, but we get 10 here. Okay, we add 10 to that. So f of 0 is equal to 10. So therefore, what we can see here is f g of 1 is equal to 10. Okay, so that's the solution to part A. For part B now, we're looking to find gf of minus 3. So what I need to do here is substitute minus 3 into f of x. So f of minus 3, so that's going to be 2 lots of minus 3 squared plus 10. So what am I going to get here? Minus 3 squared is 9, so positive 9 there, just be careful with your signs. We then times it by 2, so 9 times by 2 is 18, plus 10 gives me 28. Okay, so f of minus 3 is 28, and then what we do is we substitute this into g of x. So what we're doing now is finding g of 28. Okay, so g of 28, we just substitute 28 here. I'm going to do 28 minus 1, giving me 27 there. Okay, and there we have it. So therefore, for gf, so gf of minus 3, that's equal to 27. Okay, and there we have it. So that's our solution to that practice question. So that brings us to the end of this video on composition of functions. In the next video, we're going to take a look at inverse of functions, or inverse functions.